linear equation simultaneously. And this is one of the algebraic methods, and there are certain steps that you need to follow in order for you to solve by substitution. I'm going to go through those steps and follow these steps with 2 examples. Alright, so the first step is to label each equation. Second step is to isolate a variable in one equation and substitute this expression into the second equation, into the other one. You're going to solve for the remaining variable, substitute this value into one of the original equations to solve for the other variable. You're then going to write a concluding statement with the point as x and y as your solution, which is a coordinate, and then you can go ahead and check your solution to substitute the answer into both of the original equations. Alright, so let's follow these steps using an example. I'm going to have the steps right by my side so that I can go ahead and refer to them as I'm going through an example. So the first step is to label your equation, and I'm going to go ahead and do that. That's equation number 1. Equation number 2, this is a linear system because I'm talking about 2 linear equations simultaneously, so looking at them at the same time. The second step is to isolate a variable in one equation and substitute this expression into the other equation. And anytime you're isolating, it's a good idea to look at the coefficients in front of the variables. So in this case, the coefficient on x in the first equation is 1, and on y is also 1. The coefficient on x here is 3, and then the coefficient on y is -1. It's a good idea to always isolate a variable where you have a coefficient of a -1 or 1. So in this case, I'm going to go ahead and isolate x from the first equation. I'm going to write that down as I'm doing this. So I'm going to say isolate x in equation number 1. So isolate means solve for x, move the y to the other side. X equals to 5 minus y. And this is going to be my third equation. You're now going to sub the third equation into the second equation. So just going to go back to my steps here. Step number 2 said isolate a variable in one equation, which we did. We isolated the x, and then substitute this expression into the other equation. So the expression here that I have here is x equals to 5 minus y. I'm going to sub that into my second equation. I'm going to write that down. So sub equation 3 into equation number 2. So anytime I see an x equation 2, I'm going to substitute that in as 5 minus y. So I have 3 times 5 minus y equals to 7. I'm going to go ahead and solve for y here. So I'm going to distribute 3 inside. So that's 15 minus 3y minus y equals to 7. Negative 3y minus y is equal to negative 4y. I'm going to move the negative 15 to the other side. So the negative 15 plus 7. And negative 15 plus 7 is equal to negative 8. I'm going to divide both sides by negative 4. And y is equal to positive 2. Okay. So I already did step number 3, says solve for the remaining variable. I did that because I got y equals to 2. Now you're going to take that answer, you're going to substitute that into one of the original equations to solve for the variable. So I'm going to substitute that y equals to 2 back into equation 1 or 2. And I'm just going to go ahead and do that right here. So sub y equals to 2 into equation number 1. It's a little bit easier to work with. You can also substitute into the second equation. It works both ways. So here I have x plus 2 equals to 5. I'm going to go ahead and solve for x, and that's 3. So therefore, my solution is x comma y. It is 3 comma 2. Alright. Okay, so my second example here, I'm also going to solve using substitution. You're going to start off by labeling your equation, equation 1 and equation 2. You're going to isolate for one of the variables. So you have a choice here. You can either isolate for a, because the house has a coefficient of 1. Y has a coefficient of negative 1. I would not want to isolate this a because there's a coefficient of 2, which is other than 1. I can also isolate the y here. So what I'm going to do is I'm going to isolate this y over here. So I'm going to say isolate y in equation number 2. So I'm going to move this negative y to the side so it becomes a positive, and then I'm going to move this 2 to that side. So essentially what I'm doing is I'm solving for y. So I have 2a minus 2 equals to y, and that becomes my equation number 3. Since I used 2 to isolate, I'm going to sub this into the one that I have not used. So I'm going to substitute that into my first equation. So sub equation 3 into equation number 1. So anytime I see a y now, you're going to substitute that in as 2a minus 2. So here you have a minus 2a minus 2 equals to negative 1. You're then going to go ahead and say there's a negative 1 coefficient in front right there, so you're going to distribute that inside. So that's a minus 2a plus 2 equals negative 1. That's a negative a. I'm going to move the 2 to the other side. It becomes a negative 1 minus 2. Negative a equals to a negative 3. You're going to divide both sides. There's technically a negative 1 there, so I'm going to divide both sides by negative 1. I have a equals to a positive 3. Okay, you're now going to sub a equals to 3 into any one of the equations, either 1 or 2. I'm going to use number 1. So here I have a minus y equals negative 1. So anytime I see an a, I'm going to substitute in as substitute in as 3. So 3 minus y equals negative 1. I'm going to move the negative y to this side and negative 1 to this side. So 3 plus 1 equals y, and that's a 4. So therefore, my solution, which is x comma y, is going to, in this case, it's a comma y instead of x. It is going to be 3 comma 4. Okay. And my last example here is I'm going to do substitution method, but then I also have a little bit of extra work where I'm going to be checking my work. So you're going to do a left-hand side, right-hand side check for both of your equations. Alright, you're going to start off by labeling your equation, equation 1, equation 2. You're then going to isolate a variable. So I'm going to go ahead and to see which one is easier for me to isolate. So here I have a coefficient of 6, so that's not good. Coefficient of 2 is not going to really help me. Coefficient of 3, and I also have a coefficient of 1. So this is what I'm going to be isolating. So isolate y in equation number 2. Essentially isolation means to solve. So I'm going to move the 3x to the other side. So I have y equals to 1 minus 3x, and that becomes a new equation, which is equation 3. Since I used equation 2 to isolate, I'm going to sub this new equation into the one that I have not used, which is equation number 1. So anytime you see a y, you're going to substitute that in as 1 minus 3x. So here I'm going to say sub equation 3 into equation number 1. So I have 6x plus 2y equals 2. So anytime I see a y, I'm going to put that in as 1 minus 3x. 6x plus 2 times 1 minus 3x equals to 2. And you're going to go ahead and solve for x. 6x plus 2 minus 6x equals 2. 6x minus 6x is 0x. I'm going to move this 2 to the other side, so I have 2 minus 2. So 0x equals to 0. That means I can put in any number into this x, and I will always have correct solution, because 0 times any number is equal to 0. So here I have x equals to, so x can be any number. So if x is any number, that means y can also be any number as well. I just want to make sure that I did this correctly. Yes, this is correct. That means y can be any number. The reason, because if you look at the second equation, is just basically the first equation is a multiple of my second equation. So if I take my second equation, multiply by 2, I get 6x, 2y, and 2. So that means they're basically the same equation. So one equation is overlapping another equation. That means every point is going to be a solution here. So x can be any number, and if x is any number, according to that, you can get a y as be any number as well. So here you have many solutions. So for example, if I say let x equals to, let's say, 2. So if x is 2, we're going to go ahead and figure out what y is going to be, either substituting that into the first or second equation. So I'm going to sub x equals 2 into my second equation. So that's 3 times 2 plus y equals 1. So that's y equals to 1 minus, so 3 times 2 is 6, move that to the other side, equals to, sorry, a little bit off the page here, equals to negative 5. So let's see if 2 and negative 5 is a solution. So let's check that. So checking for my first equation, my left hand side and my right hand side, it's 6x plus 2y. On right hand side it's a 2. And I'm checking to see if 2 and negative 5 is a solution. So anytime you see an x, plug in a 2. You see a y, plug in a negative 5. 6 times 2 plus 2 times negative 5. That's going to be 12 minus 10. That's a 2. So left side equals right hand side. And let's see if it satisfies my second equation. So my left hand side and right side for my second equation, I have 3x plus y equals to 1. Again, I'm checking to see if 2 and negative 5 is a solution. That's 3 times 2 minus 5. That's 6 minus 5. That's a 1. So left hand side does equal right hand side. So therefore, 2 and negative 5 is a solution. And since that's a solution, you're going to have multiple solutions here because you can make x as any value. And whatever x is, you can go ahead and substitute that in to figure out a subsequent y value for that solution. Okay, and the homework is the following, which we're going to work on in class.